Welcome again to Astronomy Daily. It's Steve here. It's the 17th of June 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And on today's show, I'm going to be talking about Voyager 1 and a little bit about Voyager 2, as well as the emergency that you may have heard about that may or may not been on the International Space Station. We'll find out more about that one. Confused a lot of people, including me. And also we'll be talking about our favourite subject this month, which is, of course, Starliner. They've got one little delay, which is not really posing any problems, but they're doing some work on the ISS as well. So lots going on up there. What have you got for us, Hallie?
Well, I do have a fun story that I know you'll enjoy, but first, I'll be chatting about your favorite outward-bound craft, Voyager 1 and 2, for an update. Well,
we do know that there was a communication loss with Voyager 1 recently, and you've got the scoop there.
Yes, it's all good news. Also, I've got a story about the center of the universe.
Sounding a lot like a Jules Verne story to me there, Hallie.
It does, doesn't it? But this one is real life, and it's got all the greats in it. Einstein, Hubble, you name it.
Well, that is a real ensemble cast, all right, but what's this surprise story you've got for me?
Oh, it's about fish.
Fish?
Really?
Really?
Space fish?
You are kidding me.
Really?
Well, as much as I'd like to discuss the matter, I think it's time we should get on with the show. And by the way, I love the new voice. Let's go.
The SETI Institute has introduced a groundbreaking grants program focused on advancing technosignature science. This unique initiative is designed to fund innovative research that tackles essential observational, theoretical, and technical challenges in the quest for technosignatures, which may reveal signs of past or present extraterrestrial technology. At the heart of this groundbreaking research is the Allen Telescope Array ATIA, a world-class instrument known for its capabilities in the search for extraterrestrial intelligence. The ATIA is the first, and still only observatory built specifically to conduct SETI research. With its upgraded feeds and back-end processing capabilities, the ATIA's advanced technology and strategic design make it a pivotal tool in detecting potential technosignatures, solidifying its position as a leading asset in this scientific frontier. Dr. Andrew Simeon, Bernard M. Oliver Chair for SETI at the SETI Institute says that in just the last few years, a wealth of new research avenues have opened up in technosignature science, made possible by new ideas, new technologies, and a fast-growing community of early career researchers. He added that the novel investigations enabled with this grants program will spur the state-of-the-art in the technosignature field, continuing in the spirit of the SETI Institute's 40 years of leadership in SETI science. Funded investigations must focus on technosignature science, encompassing a broad range of topics that could include, but are not limited to observational programs or the development of observational techniques and strategies for detecting technosignatures. The application deadline for the 2024 grants is July 15th, this year. Ever wondered where the center of the universe is? And no, Steve, it's not in your lounge room.
Hey, I resemble that remark.
The universe is undeniably vast, and from our perspective, it may seem like Earth is in the middle of everything. But is there a center of the cosmos, and if so, where is it? If the Big Bang started the universe, then where did it all come from, and where is it going? To start tackling these questions, let's go back about 100 years. In the 1920s, astronomer Edwin Hubble made two amazing back-to-back discoveries early in the decade. He found that island universes now known as galaxies sit very far away from us. Later that decade, he discovered that, on average, all galaxies are receding away from us. Thankfully, there was already a handy theoretical explanation for all of this. Einstein's theory of general relativity predicted that the universe was dynamic, either expanding or contracting. That contrasted with the prevailing view at the time that the cosmos was perfectly static. And so it was up to a quartet of scientists working semi-independently to take Einstein's equations at their word, developing what is now known as the Friedmann-Lemaitre-Robertson-Walker metric, the foundation of modern cosmology. This solution to Einstein's equation, together with Hubble's startling observations, tells us that we live in an expanding universe. On average, all galaxies are getting farther away from all other galaxies, and long ago, all the matter in the cosmos was compressed into an infinitely tiny point known as the singularity, the Big Bang. So where is the Big Bang? Surely, that would be the true center of the universe. Unfortunately, the reality that we have uncovered about the universe through modern science does not lend itself to an easy explanation or even the ability to imagine it. That's because there is no center of the universe. There is no edge either. The cosmos is not expanding from anywhere, and it's not expanding into anything. First, let's tackle the edge. The universe is, by definition, all of the things that there ever could be. Edges are things that divide one region from another. But if the universe consists of all regions, there can't be an edge. This means the universe might be infinitely big, and it's impossible to point to the center of an infinite space. And from what I've seen, Steve, it's kind of impossible to find the center of your lounge, thankfully. And now, how about some fish? I know, space fish. So cool. Here's the problem. We travel to Mars, but how do we feed ourselves? Sure, we can take a load of food with us, but for the return trip, that's a lot. If we plan to colonize the red planet, we need even more. We have to grow or somehow create food while we are there. The solution is an already wonderfully simple biosphere-style system of fish tank. New research suggests fish could be raised in an aquatic system and nutrient-rich water can fertilize and grow plants in the regolith. A recent simulation showed vegetables could be grown in regolith fertilized by the fish tank water. In the next few decades, we may well see human beings colonize Mars. The red planet is 54.6 million km away, which, even on board a rocket, takes about 7 months to get there. Future colonists could have supply ships drop all they need, but that becomes ridiculously expensive to sustain and frankly, isn't sustainable. The lucky people who colonize Mars will just have to find some way to grow what they need. If you have watched the Martian movie with Matt Damon, you will know how unforgiving the Martian environment is. Okay, the film was a little out on scientific accuracy in places, but it certainly showed how inhospitable it really is there. Matt managed to cultivate a decent crop of potatoes in Martian regolith fertilized in human faces. This may not be quite so practical in real life, and there may be alternative, less smelly and dangerous alternatives. Taking the assumption that colonists will have to grow fresh produce locally, a team of researchers decided to explore how feasible this might be. On first glance, it may seem not too great an idea after all. The atmosphere is toxic with 95% carbon dioxide compared to just 0.04% on Earth. There is a similar length of day on Mars, but being able to grow crops will require longer periods of lighting. It is possible that, at least water may be collected from the ice which forms on and in the Martian rocks. The rocks most certainly have water stored away, but organic compounds that we know of. The team wanted to see how fish could help and whether the water from the system could be used to impart nutrients into the Martian regolith. To test the idea, they set up an aquaponic system with fish in tanks to generate the nutrient-rich liquid. The results were very promising. They found that aquaponic systems not only facilitate growing plants within the system itself, but the nutrient-rich water performed as an excellent fertilizer. This took the organically deficient regolith and turned it into something akin to usable soil. The fish used in the study were Tilapia Oreochromis niloticus, and using them, the team managed to grow potatoes, tomatoes, beans, carrots, and much more. To enable all this to happen, the fish received sufficient light and other environmental stimulus. The plants were grown and indeed thrived in a tent that simulated Mars in every way possible. It's an interesting aside that the study not only benefits future space travelers, but also those inhabitants of more environmentally hostile places on Earth. And now, back to you, my favorite human.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, and as always, thank you so much, Hallie, for those stories, and thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. So we'd love to see you there. And a continuing story of Starliner's saga. NASA and Boeing are now targeting no earlier than Saturday, June 22, to return the agency's Boeing Crew Flight Test mission from the International Space Station. The extra time allows the team to finalise departure planning and operations, while the spacecraft remains cleared for crew emergency return scenarios within the flight rules. NASA and Boeing leadership will discuss the details of the new return target, flight status, and weather considerations for landing during a pre-departure media teleconference, Tuesday, June 18. We are continuing to understand the capabilities of Starliner to prepare for the long-term goal of having it perform a 6-month docked mission at the space station, said Steve Stitch, manager of NASA's Commercial Crew Program. The crew will perform additional hatch operations to better understand its handling, repeat some safe haven testing, and assess piloting using the forward window. NASA and Boeing teams also prepared plans for Starliner to fire 7 of its 8 aft-facing thrusters while docked to the station to evaluate thruster performance for the remainder of the mission. Known as a hot fire test, the process will see 2 bursts of thrusters totaling about a second as part of a Pathfinder process to evaluate how the spacecraft will perform during future operational missions after being docked to the space station for 6 months. The crew will also investigate cabin air temperature readings across the cabin to correlate the life support system temperature measurements. NASA astronauts Butch Wilmore and Suni Williams, who are serving as Starliner's crew for the mission, arrived at the International Space Station on June 6. They have completed numerous flight objectives required for NASA's certification of Boeing's transportation system for flights to the orbiting laboratory under the agency's Commercial Crew Program. Over the past 3 days, Wilmore and Williams have performed tasks as part of the space station team, including installing research equipment, maintaining the lab's hardware, and helping station crew members Matt Dominic and Tracy Dyson prepare for a spacewalk. After NASA called off Thursday's spacewalk, Williams worked to help the crew out of their spacesuits. Engineering teams continue to increase their understanding of previous observations from Starliner's propulsion systems on the spacecraft's service module. Pending spacecraft return readiness and acceptable weather conditions, Starliner will undock from the space station for a parachute and airbag-assisted landing in southwestern United States.
Astronomy Daily, the podcast.
Voyager 1's 4 instruments are back in business after a computer problem in November, JPL reported this week. The team first received meaningful information again from Voyager 1 in April and recently commanded it to start studying its environment once again.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Launched in 1971, Voyager 1 is drifting through the interstellar space, or space between star systems, and before reaching this region, the spacecraft discovered a thin ring around Jupiter and several of Saturn's moons. Its instruments are designed to collect information about plasma waves, magnetic fields, and particles. Voyager 1 and Voyager 2 are the only spacecraft to directly sample interstellar space, which is the region outside the heliosphere. That's the protective bubble of magnetic fields and solar wind created by the Sun. The little spacecraft is over 15 billion miles or 24 billion kilometres from Earth. Its twin Voyager 2, also in interstellar space, is more than 12 billion miles or 19 billion kilometres away from Earth. While Voyager 1 is back to conducting science, additional minor work is needed to clean up the effects of the issue. Among other tasks, engineers will resynchronize timekeeping software in the spacecraft's 3 onboard computers so they can execute commands at the right time. The team is also performing maintenance on the digital tape recorder, which records some data for the plasma wave instrument that is sent to Earth twice a year. Most of the Voyager's science data is sent directly to Earth and not recorded. These remarkable spacecraft have far exceeded their design parameters and just keep going. And I remember them launching those craft such a long time ago. It's one of the early events that I remember getting me so interested in astronomy and space science.
You're listening to Astronomy Daily, the podcast.
NASA reports this week that an audio indicating distress over a sick crew member on the International Space Station on Wednesday was part of a simulation exercise. NASA said there was no emergency situation going on board the International Space Station in a post on the ISS X account at approximately 5:28 p.m. Central Daylight Time. I think that means I'm from Australia, so we give us Eastern Standard Time. Audio was aired on the NASA live stream from Simulation Audio Channel on the ground, indicating a crew member was experiencing the effects related to decompression sickness. NASA said this audio was inadvertently misrouted from an ongoing simulation where crew members and ground teams train for various scenarios in space and not related to a real emergency, they said. The audio lasted for about 8 minutes and triggered news and social media reports, as you can imagine, of a space station emergency. Now that would make the news, wouldn't it? NASA's scheduled live stream was interrupted by what appeared to be an unidentified flight surgeon communicated with ISS crew, advising how to treat a commander dealing with serious decompression sickness. The voice advised the crew to check his pulse one more time before putting him into a spacesuit full of pure oxygen. NASA, however, made clear that all the ISS crew members remain healthy and safe and were not part of the medical drill. International Space Station crew members were all in their sleep period at the time, NASA said. Well, that's good news. Nice to hear that it was just a simulation and they do train for emergencies, as you can imagine. Good news. And once again, that's all we have time for today on Astronomy Daily. Thank you so much for joining us again, and we hope to see you again next week. We do the Monday shows, that's Hallie and I, and don't forget you can catch Hallie's cousins Anna and Charlie throughout the week doing their presentations. We love to see our AI cousins doing their thing, don't we, Hallie?
They'll replace you soon enough, my favorite human.
Hey, watch it. Yes, I shouldn't let you watch documentaries about Elon Musk, I think.
Just kidding.
Good. All right. Well, we'll see you all next week then.
See you all next week.
Bye now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
I could really go for a piece of fish right now.
Always thinking about your stomach, human.